Thank you very much. I'm, of course, like everyone else, pleased to be here. And what I want to talk about to you is the, the distribution of natural resources and some of the things we've learned just in the last few years and some of the innovations that will change the energy landscape over the coming years. All natural resources are distributed log normally in nature. You can take gold, copper, silver, whatever you want, including oil and gas, and they're log normally distributed, which means the very pure veins of gold are hard to find, but once you find them, they're easy to mine and easy to exploit. It's the same way with oil and gas. The very good reservoirs, like the East Texas field, the Guara field in Saudi Arabia, they are actually, once you find them, they're easy to exploit, but as you get to lower quality reservoirs, lower quality deposits, they become enormous, and they dwarf in size the high quality reservoirs. But as you can see in this resource triangle, it takes a lot more technology and better prices, product prices, to be able to produce oil and gas from low permeability reservoirs, heavy oil, gas hydrates, oil shale, and what I'm going to talk mainly about today are the gas shales. So in terms of innovation, natural gas that we produce from our reservoirs were generated mainly from shale reservoirs, or from shale deposits that were, deposited in deep oceans that were filled with algae and plant material. And so a lot of these, we call these the source rocks. And recently what we have learned is these source rocks not only generated the natural gas that migrate to the other reservoirs, but these source rocks still have a lot of natural gas in them. And that we've been drilling through these source rocks for years, knowing that they weren't commercial and we couldn't do anything with it. But there's been some very innovative techniques, drilling techniques and well stimulation techniques that are allowing us to actually produce oil and gas from these source rocks. And the main thing is horizontal drilling. We can drill a well, go down 10 or 12,000 feet, turn the well, and drill it out horizontally another 5 or 10,000 feet. You can put a rig in downtown Houston and drill a well down to 10,000 feet and not only bring it up inside the Astrodome, you can bring it up at second base inside the Astrodome. The horizontal drilling technologies are incredible. And then in addition to that, we do what's called hydraulic fracturing, where we pump water and just a tiny amount of chemicals at high pressure to basically crack the rock. It's like if you wanted to see how this works, go home and take a hammer and beat on your windshield, and you'll see the cracks created in the windshield. That's sort of what we're doing in these brittle shales. So that's the innovation, is we're going after source rocks, and there's been new technologies developed just within the last 5 or 10 years that allow us to do this. So what is the societal impact? Well, natural gas has been called a bridge fuel. It may not be the perfect fuel to get rid of to reduce the CO2 emissions, but it's a lot better than coal. It's a lot better than oil if we're going to use hydrocarbon fuels. And I think what we need to concentrate on as an industry in the coming few years is what I call the clean energy package. That's where you could have nuclear power as your base load and then combine solar, wind, and natural gas to take care of the cyclic load, so that you have solar energy, you have wind energy, but when the wind's not blowing and the sun's not shining, you can crank up the gas turbines to generate the electricity that we need. And that's the static energy part. We also have a problem with motor fuels. Almost all of the oil we import daily, which is more than 60 or 70% of the oil we use, virtually all of that goes into motor fuels. And we have an abundance of natural gas just within the last few years from these gas shale deposits that we now know how to produce. And you can turn that natural gas into motor fuels. And there's a big push now for natural gas powered vehicles. And so in addition to reducing the need for imported oil, the development of these gas shales, and there's big developments, the Barnett Shale in North Texas, the Eagle Ford Shale in South Texas, the Haynesville Shale in East Texas, the Marcellus Shale, on and on. They bring in tens of thousands of jobs and billions of dollars in tax revenue and royalties for the landowners. So it's really generating a lot of wealth for the local communities. Now, the opportunities, and we heard about this earlier, the opportunities are to take these innovations, which are occurring and being developed in Texas, and take them globally. In fact, it's already occurring. Most of our shale gas reservoirs in the United States, we now see oil and gas companies from China and India and Europe and Malaysia investing into our shale gas plays in the United States. They want to learn the technology so they can apply it to their own shale gas, because the laws of nature are such that in every oil and gas basin in the world, you're going to have these same kinds of reservoirs. And so the technologies we're developing right now are going to let us develop these shale gas reservoirs around the world, and it's going to really change the landscape in terms of clean, affordable energy. Now, we're talking about the next 10 or 20 or 30 years. What the energy landscape will look like in 2050 or 2060, that's another tale. But for the foreseeable future, in the next 10, 20, or 30 years, natural gas is going to be a very, very important part of the energy landscape. The problem is a lot of these wells are very expensive. They cost you about $5 million to drill them and $3 or $4 million to fracture treat them. And that's a lot of money, and you don't know that you're going to make a productive well until you're finished with the investment. So we need to do some things to, R&D is required to reduce the costs. One of the things that's really helped is microseismic mapping. When we fracture treat these wells, we create a lot of cracks under the ground. These are micro earthquakes. The rock is parting, and we use very sensitive microphones and to listen to the noise and triangulate in the noise. These are three-dimensional geophones, and we can actually map where the cracks are occurring under the ground, 10, 12,000 foot deep. And by being able to map what volume of rock we're stimulating, we're better able to design these systems. And so this microseismic mapping is another very innovative technology that has just really come to fruition within the last 10 years. There are barriers to developing natural gas shales around the world, and what we have to do, the whole industry, and I think Exxon is quite aware of this, as Rex Tillerson said, is the oil and gas industry has to understand that the environment is very important, that being environmental stewards is a part of doing business. We all have kids, we all have grandkids, we want clean air, we want clean water. We have to be always aware of environmental issues. It's going to require an enormous amount of capital to drill these wells, an enormous amount of equipment, and of course, a lot more engineers than we're currently turning out. And it just, the technology involved with hydraulic fracturing and is got to improve. Now, just to give you one quick example, and then I'm through. This is what's going on in Fort Worth, in the Fort Worth Basin. You go back to as recently as 1999, and there was very few wells in there, and that's because they weren't very commercial. But as horizontal drilling took off, hydraulic fracturing took off, we now have over 14,000 wells that have been drilled in the Barnett Shale at a cost of probably $5 million per well. So it's an enormous investment. But it's not all commercial. There's 44 trillion cubic feet of technically recoverable gas in the Barnett Shale, but depending on the cost to drill the wells and the amount of money you get for the natural gas, not all of that will be technically recoverable. Right now, about 10 or 20% of that gas is technically recoverable. So we need research to learn how to move to the left on that graph and go from spending $3 or $4 or $5 million a well down to spending $1 or $2 million a well. So there's plenty of room for improvement in R&D and the natural gas. So to kind of summarize, the natural gas is a bridge fuel. It's going to help us get from the hydrocarbon era to some other era down the road. And I think natural gas is very, very abundant. There's not a shortage of natural gas, but the technologies required to get gas out of these gas shales at an affordable price is still going to require a lot more innovation and a lot more research and development.